Calculus kids, this is Dr. Callahan with week 5 Tuesday. How are you guys doing? Today we're going to go ahead and talk about the derivatives and integrals of ln. So it's a continuation of Monday. So pause the video and answer the following 3 questions on your warm-up. Okay, so let's go ahead and create the assignment for those of you guys who have hybrid days for today. So this is going to be for week 5 Tuesday, AP Calculus semester 2. And your topic today is going to be the derivative and integral of natural logs. Your instruction is, oh, that's not it. Is to go ahead and view the assignment, watch the video in its entirety, and then make sure you upload the assignment from what you accomplished today. There are 2 different links for you guys for this class. Make sure you're checking in with me from 8:40 to 9:29. That is your time frame. And as always, your assignment is due by 3 p.m. So let's go ahead and sign that. All right, so with that said, let's go ahead and just jump in and get this going. So looking at this part here, this is the breakdown of your tasks today. So go ahead and take a look at this. Your guided notes today is going to be on week 5 Tuesday. And there are a few pages. Your first page here looks like this right here, which goes over some examples from the textbook that you can go ahead and take a look at. Next, you have a few examples here on the background of differentiation. This is a practice one right here from your textbook directly on finding the derivative. And then, of course, you have your link right up here if you want to watch the video that goes along with this. And so then it comes to today's notes, which is going to be on this page. This page right here is going to be the derivative of ln, or natural logs, and then integrals of natural logs. All right, so with that said, let's go ahead and get started right here. So the goal right here today is to find the derivative of natural logs as a continuation from yesterday, but today we'll do a little bit more complicated problems. Then our second goal is to find the integral of ln using u sub. So we'll just kind of use them back and forth and ensure that you guys get both of them, and so you're not confused about how to find the natural logs, the derivatives, and how to find the integral of derivatives. So let's get started on this page right here. I'm going to go over these 2 examples. So go ahead and turn over to that. All right, first example. You have y ln x plus y squared equals 0. So obviously, if you look at this, it is a multiplication. So here you have y times ln x. So most likely you have to use the product rule. And so let's go ahead and do that. Your product rule means f is going to be y. So f prime is 1. G is ln x. So g prime is 1 over x. You're going to go ahead and do the product rule for this. So you could say f prime of x is equal to f prime times g. So 1 times ln x is ln x plus f times g prime. So that's going to give me a y over x. Okay, so next what's going to happen is I'm going to find the derivative of y squared, which is going to give me a 2y. And then just keep in mind that whenever you find the derivative of y, it's a dy over dx. So make sure you actually find that. And in addition to that, just keep in mind that I actually missed one here because the derivative of y is 1, but because there is a 1, there has to be a dy over dx. So when you do the f prime times g, there is actually a dy over dx in front of that. So just make sure you don't forget that. Equals the derivative of 0 is just going to be 0. So here you have an implicit differentiation, if you guys remember that still, and that is you need to solve for dy over dx, and you want to isolate it. So let's go ahead and do that. So if I go ahead and take out the dy over dx, there are two terms I want to keep here. First term right here, second term right there. Everything else, I kind of want to push it over to the right side, so that's going to go over. So that's going to be a negative y over x. And here I have a dy over dx ln x plus 2y. And then you know you're going to divide this on both sides. So you have a dy over dx is equal to negative y over x. And if I divide it, it's going to have a ln x plus 2y in the denominator. And this is actually going to be your answer. The only other way you can rewrite this is if you distribute the x in there. So you have an x ln x plus 2xy. And that is your answer, you guys, for the dy over dx. All right, let's go ahead and take a look at the second example. Example 2, you have ln x plus y equals x. Okay, so looking at this one here, you will have to use a u substitution, obviously, because this is where the chain rule occurs. So I'm going to say let u be x plus y. U prime is going to give you derivative of x is 1. Remember the derivative of y is also 1, but because it's a derivative of y, you have to put in a dy over dx, okay? So then you're just going to go ahead and replace this as ln u. The derivative of ln u is 1 over u times u prime. So then naturally I'm going to replace this part with a 1 over u, which is x plus y. U prime, I'm going to replace that with a 1 plus dy over dx. Make sure to put parentheses. Equals derivative of x is just 1. Okay, so then our goal here is to solve for dy over dx. And looking at this part right here, I'm going to get dy over dx by itself, but first I need to get rid of the 1 over x plus y. So I'm going to multiply x plus y on both sides. And that way you can cancel this. So f prime of x is equal to 1 plus dy over dx equals x plus y. And then, of course, dy over dx is equal to, you subtract the 1 on both sides, x plus y minus 1. And this is your answer. All right, so now that I went ahead and practiced with you guys on the two examples, go ahead and pause the video and practice with the following ones right here. You have 7 examples, and I've included the answers for you as well, so give that a try. Okay, so let's go ahead and jump into integrals of ln. Okay, so let's go ahead and proceed forward with integrals. Make sure you turn over to this page right here, and I'm going to go over the questions with you guys. Okay, so you know that the integral of 1 over x is equal to ln x plus c. So our goal here is you want your answer, you want to manipulate the question. So you have the integral of 1 over x. So let's start out with something easy. How do I manipulate this so I can get this equation to look like the integral of 1 over x? I have a 2 right here, so let's just going to move that over. Well, there you go. 2 ln x plus c. So that was fairly simple. And that's good because, the next one obviously is not as simple as that. So let's take a look at example 2. With example 2, you're going to have to use a u substitution. So let's let u equals 1 over 4x minus 1. I'm sorry, hold on. U is equal to 4x minus 1. So then your du is going to be 4 dx, and your dx is equal to du divided by 4. So let's go ahead and rewrite this. Integral 1 over u. Replace your dx with a du over 4. Move the 4 or the 1 over 4 over to the left, which is the integral 1 over u du, which is perfect because it is in terms of u and it's 1 over u. So then looking at this, you will just go ahead and proceed on with the integration. You get 1 over 4 ln u plus c. Replace it. Ln u becomes a 4x minus 1, and then plus c, which is your answer. All right, let's go ahead and move on to the next one. Take a look at example number 3. So with number 3, this is a definite integral. So with this one, you will have to use a u substitution. So let u be x squared plus 1. Du is 2x dx. Dx is equal to du over 2x. And I'm just kind of glancing at this right now, and immediately I can see that there's an x there, which most likely would cancel with this x when I use u substitution. So let's move forward with this. X over u times dx. Replace the dx here with a du over 2x. And I was right, this part will cancel. So I have a 1 over 2, integral 0 to 3, 1 over u du. So the integral of 1 over u is just going to be a ln u plus c. Evaluate that from 0 to 3. So I'm going to replace the u with the x squared plus 1. I don't need to worry about the c right there. And then so what you're going to do is you're going to plug in your upper and lower bound. So 1/2, and then just plug in your upper bound minus your lower bound. And that should give you an answer. Okay, let's go ahead and take a look at example number 4. Okay, so with example number 4, you have a numerator and a denominator, and you're like, okay, which one do I want u to be? Generally, what you would like to do is you want to have the denominator to be set for u, and the reason for that is because, I'm going to write it down, set denominator for u sub. And the reason for that is because if you use the numerator, you're going to notice that your x's are not going to cancel, because if I have the u sub on top, then the denominator here with the x cubed plus x is not going to be able to cancel. So if I say let u be the numerator, 3x squared plus 1, du is going to be 6x dx. Dx equals du over 6x. Okay, so immediately I know that this part is going to be a u. But then I have 6x in the denominator, so how am I going to cancel that with x cubed plus x? So you realize that you are just stuck, but it's okay to go ahead and try that, okay? Just so you know how far you can get with it and its limitations. So let's use the denominator instead. Let u be x cubed plus x. Your du is 3x squared plus 1 dx. And that's perfect because look, if I solve for dx, it's going to give you a du divided by 3x squared plus 1. And that's exactly what I want to cancel the numerator. So then my integral is 3x squared plus 1 over u times, go ahead and replace your dx with a du over 3x squared plus 1. And you're fortunate enough to cancel that. So you have the integral of 1 over u du, which is just going to be ln u plus c. But then your last step is replace the u, which is going to be x cubed plus x plus c. And that is your answer. All right, so I'm going to have you guys go ahead and work on 5 and 6 on your own. And if you are ready for the answers, here are the answers for all 6 questions. And then for the rest of the class period of the remaining 55 minutes, I would like you guys to go back to your guided notes, which is going to be right here, and start practicing with some of these examples right here. If you need assistance, I do have the link of the videos that coincide with this. All right, you guys, I hope you will have a wonderful week. And as always, stay safe and healthy. And I'll see you guys next time. Take care.